Hello and happy holidays. Rod here at A Better Way to Farm, where we spend every day helping growers increase yield and improve profitability. Guys, we're excited to get to do these. This is the 12 Days of Nutrients as a series, and we hope that you find value in these, and if you do, share it with a friend. So tonight we're going to do day 2, and day 2 is on phosphorus. So let's talk about what the first cheat sheet you run across says about phosphorus, and that would include things such as it's involved in photosynthesis, respiration, energy storage, cell division, and cell enlargement. It promotes early root growth. It improves the quality of the fruit, vegetable, or grain. It's very vital to seed formation, and it increases water use efficiency. It also hastens maturity. Everything we do is geared towards helping you have a plant that matures quicker, that actually it will dry down in the fall instead of die down. And the right form of phosphorus in the right place, applied at the right time, will go a lot ways down the road in order to get that done. Guys, I'm very excited about this. This is one of the big 3. It's one of the micros, as you know. And so we're going to dive in here and grab some things out of the books that I've ran across that were interesting. And then we're going to talk about some of the things that we have learned over the last 29 years as we work this. One of the things that's really, really important, and I want to start with this, is this. Since phosphorus reacts quickly with other things in the soil, it only moves a short distance, frequently less than 1 inch. And actually, other books that I've looked at would say 6 millimeters a year is your phosphorus movement. Therefore, phosphorus from a surface application does not penetrate soil to any appreciable difference and will be much more subject to positional unavailability when the soil surface is dry. Let's talk about where that's really important. And I'm not going to get into the tillage thing because there are guys who are very successful that no-till, and there are guys who are very successful that don't. And I don't want to have that. This isn't about having an argument, guys. It's about finding what works in your system. Here's what we know. If you no-till and you're broadcasting phosphorus on the top and it's only going down 1 inch, you're cheating yourself. Because the fact of the matter is you're probably planting 2 inches deep, and yet that phosphorus won't go down more than 1 inch. Now, if you're tilling, you can incorporate it and get it down farther, obviously. It's still not going to move. And I say all of that because the fact of the matter is this. Putting phosphorus on in the band is by far the single best way to do it. No matter who you talk to, no matter what book you read, they're going to push us towards that. Now, as we go in here and we look at some of the things, I want to talk a bit about soil testing. I had someone here the other day, he sent me a message and he was looking at some of our soil tests and he said, why do you not use the Mehlich method? Well, the reason that we don't like the Mehlich method is that we believe to a very large degree that testing, we need to get a P1 and a P2. What is the difference between P1 and P2 phosphorus? P1 is what's readily available, water soluble, ready to go. P2 is what's going to become available. That ratio in and of itself tells us a lot. In a perfect world, the ratio is 1 to 2. In other words, a P1 of 25, a P2 of 50. That's perfect. When that ratio, and I've seen it as much as it could be as something as maybe an 8 P1 and 105 P2, we got something there that isn't working right, or we're in very, very high calcium soils, high pH soils. I could see it the other way where it was 41 and 42. And so that tells us that we've got something different there that we need to work on, something else that we could do. P1 is readily available, P2 is less available. And when this individual said, well, why do you not use the Mehlich test? I said, why do you not want to use the Bray test and look at P1 or P2? Now, if your pH is above 7, we believe that the Olsen bicarb test is by far a better test to get us an adequate reading of our phosphorus that's in our soil. And so we would encourage you to look at that. The beautiful part about Midwest is they run a P1 and P2 through our system. They run it on everything. If the pH is above 7, they also run the Olsen bicarb, which gives us more information so we can make good decisions about that. Guys, one of the things that we know that high sodium reduces phosphorus availability. What are we going to do about that? I've talked to several of you guys who are battling high sodium soils, and it's a challenge. There's no question about that. But one of the best things that we can do, now if the high sodium is in a low pH, then we're going to want to put on quite a bit of lime, a very significant amount of lime. And if we're in a high pH soil with high sodium levels, then we're going to want to look at gypsum. And after we put on rather large amounts of these over a period of 2 or 3 years, we'll start to see some improvement in those areas to get that phosphorus to be more available and just everything to work better. Looking in Schrieffert's book here as we move forward, it's interesting to read what these different guys have to say, but yet it's almost always the same. They've all been out in the field doing research and studying. And he says, Schrieffert points out that occasionally we will not want to build the P2 level of phosphorus. In a soil condition that severely locks it up, we would instead place the phosphate in a concentrated band while trying to correct the conditions that tie it up. If the soil test indicates that limestone is needed, phosphorus should be banded instead of broadcast until the limestone problem has been corrected. Banding minimizes soil exposure in comparison to broadcasting. Guys, here's the bottom line. Banding's always better. When you look into the fertilizer handbook, when you find this little book somewhere on eBay or somewhere used, and this is put out by the Fertilizer Institute, they're going to talk about how much more efficient it is to band. Somewhere in all of my reading here, we came back across the deal where they say, and I think it's in this book right here, they talk about the fact that when we apply dry broadcast fertilizer, the best we can hope for is 10 to 30% recover the first year. You say, well, it's there and it's money in the bank. Sort of. Because the fact of the matter is, guys, you recovered at the rate of 1% per year. And so it's not a very good investment. You know, if I said, hey, I want you to invest $1 million with me, and a year from tonight I'll give you back 20% or $200,000, everybody's pretty interested at that point. But then when I say, now the rest of the story is, what I'm going to do from then on, I'm going to give you back 1% every year. Nobody wants to make an investment because why? You're going to have to live 81 years just to get your money back. Why do we want to do that? Let's talk about how we can force feed that phosphorus into that plant. Let's talk about how we can help to assure that we get P availability. Let's talk about the things that we can do that will make this better. And quite honestly, building that test may not be it. It might be a lot better served to go ahead and band it right there by the row or in the row. You know, and in a perfect world, I want to talk about that because there are, I still run across people and they go, well, I talked to so-and-so, my local retailer or my CCA or whatever it was, and he said you can never put fertilizer on the seed, to which I respond, if I'm selling their fertilizer, that is true, okay? We know exactly how our product is going to react. We know what are the conditions when it should be applied right on the seed, what are the conditions when we should use a splitter, what are the conditions that we should go 2x2, because those are all relevant based on CEC and organic matter. And so we have those charts. We know where we're seed safe. It's built right into our soil test. The soil test will come back and it will say in furrow or splitter or 2x2. And so we know what that is. One of the books that I was reading, some of the research that I did was talking about the idea of purple corn. If you guys follow me, you come to the meetings, you know I've got a couple of phrases that drive me crazy. One of them is when the person that's selling you nutrients says you'll probably get away with it. I hate that phrase because what he's saying is 1 year in 10, this is going to be a train wreck. But it's your money, not mine, so what's the big deal? Guys, I don't want something that I probably will get away with. We're never going to do that. That is reckless. We don't do reckless. And so the other phrase that I don't like is the phrase, it will grow out of it. That is the wrong question. And specifically, I'm talking about purple corn. You know, if in the spring we didn't have the forethought, the sense to band our phosphorus, to row apply our phosphorus, and it turns off cool and wet, in particular, those are really bad signs. Also, if it stays really warm and dry, because then we don't get any solubility. And those two extremes we can really end up with purple corn. That is a phosphorus deficiency. And everyone who's in the nutrient business wants to come out, put their arm around you, tell you it's going to be okay, and say it's going to grow out of it. It will. We don't harvest purple corn in the fall. We know that. It won't be purple. But the fact of the matter is this, it's the wrong question. The question is not, will it grow out of it? Yes, it probably won't die. However, the question is, what did it cost me? And in 2 of these 4 resources that I'm particularly working out of, they both said that when you have purple corn, you can just figure that you have lost 15 bushels to the acre. 15 bushel in today's dollars is well over 75 bucks an acre. That will buy all the starter that you could ever need to use for 2 years. That's not a gamble that's worth taking. And bearing in mind, when we row place starter, it replaces part of our dry program. And right now, that's better even than a dollar for dollar wash with the current prices that we have. Guys, if you are going to do dry broadcast, I want to talk a little bit about what do you want to use. My experience indicates that people who are already battling high pHs in their soil, for whatever reason, the retailers, I actually had a retailer tell one of our guys this year that they absolutely could not get MAP, that they had quit making it. MAP is 1152O, as you know. It has a pH of about 4.0, and so it is the product of choice if my pH is above 7. DAP, 1846O, has a pH of 8 or a little above. That's the product of choice where I live, where we fight low pH, where we have to continue to apply calcium. Almost without fail, the retailers in the areas are switched on what they're doing. The guys who have high pH, they're trying to get them to use a high pH fertilizer. The guys who have low pH, they're trying to get them to use a low pH fertilizer. Here where we're at, we need that extra, every ounce of help we can get on pH, we're going to take it. And so if we need to apply something, and here a while back I needed to put a little bit of dry on for a project we were doing, I called, I asked for 1846O. The guy said, no, you want 1152O. And I said, no, I don't. I want 1846O. And then he said the line that really made me chuckle. He said, you realize 52 is more than 46. I stayed relatively calm and I said, yes, but do you realize that a pH of 8 is higher than a pH of 4? Because I'm looking for what is the pH deal. So all I say is if you're going to do a broadcast, perhaps we should consider making sure we're getting the right product on when we're doing that. When we get into the book that Kinsey put out here, I got several things out of this because I find him very interesting, and especially in regards to this. So I got several things I'd like to share with you. And I want to encourage you guys, read the Fertilizer Handbook. Read From the Soil Up by Schriefert. Read Hands-on Agronomy by Kinsey. Read the Midwest Labs handbook, agronomy handbook. They're really good resources. And you can get 3 out of the 4 of them without, you can download the Midwest Labs book for free. Just print it off yourself. Facts about fertility are not highly rated in importance for most fertilizer companies, it seems. If you attend a 2-day industry-sponsored fertilizer conference, you will hear perhaps 2 lectures on fertility. They tend to concentrate on getting new accounts, holding and keeping current accounts, and keeping up with receivables. The rest is spent on government regulation. Guys, we do a 2-day Fundamentals of Agronomy course. I promise you this is not it. This is not what we're going to do. It's not about getting you to buy. It's not about getting new accounts. It's not about hanging on to the business. It's about what is going to work to make you money. Because the bottom line is we are only successful if you are successful. And so I want to invite you guys, we're doing those, we are doing those Fundamentals of Agronomy at a very rapid rate. We just finished up in Fargo, North Dakota. They're going to be in South Sioux City on Monday and Tuesday. We're going to be up by Madison, Wisconsin on Thursday and Friday. The following week, we're going to be in Kearney, Nebraska on Monday and Tuesday. We're going to be in Bettendorf, Iowa on that Thursday and Friday. And guys, I want to see you there. I want to meet you. I want the chance to get to know you. Give us a call. Send us a text at 641-919-1206, and we'll be happy to help you get registered to get into those. One thing that I had never noticed before, and I've been through these books many times, I've done this series. This is the third time for doing this series. And I do it for a lot of reasons to bring value, but I also do it because it makes me dig and learn. It's kind of like being the Sunday school teacher. I've always learned more about the Bible when I was the teacher. Why? Because I got to be prepared. And so here, doing these, I have to prepare, and it's interesting to me to see. But something that just came about here that I wanted to read was, according to the University of Illinois Extension, 2 pounds of boron will kill corn. This fellow used 4 pounds of actual boron, and if he couldn't get it on any other way, he would hire an airplane to fly it. He said it made him more corn. When asked exactly what 4 pounds of boron did for him, he said, well, it makes the cobs longer. It looks like the ears are actually getting longer because it filled all the way to the end. He said, consider phosphate first, but don't let the lack of boron fool you into buying more phosphate. And I share all of that because he talked earlier when he said, when you have 400 or 500 pounds of phosphorus, you are well past having enough. If you fail to get to the tip of the cob, the first thing to look for is a phosphate deficiency. But he said, but if the phosphate reads more than 300 plus, the problem may very well be from boron. And guys, I say that because oftentimes the industry has worked very hard to cure everything with NPK. Oftentimes when we actually have a zinc deficiency, but we make up for it because zinc translocates phosphorus throughout the plant. And so what do? We go on and we put on a lot of extra phosphorus in an attempt to hide the zinc deficiency. My question is, why do we want to spend 40 or 50 bucks on phosphorus when we could spend $10 on zinc and get better results and cure our problem, make it better next year? Because the more we just keep blowing on more phosphorus, the more zinc we're going to need. And if we don't adjust that, we're never going to get anywhere. Out of the Midwest Labs handbook, there are some things here that are really important to know. Number 1, plants absorb phosphorus primarily in the form of H2PO4, which is an orthophosphate ion. We need to understand that an orthophosphate, guys, the difference between orthophosphate and polyphosphate is like a log chain. If I have a log chain laying out here and the links are all put together, that's polyphosphate. Polyphosphate will not go into the corn plant. If I have a log chain laying out here and it's all just individual links, but none of them are tied together, that's orthophosphate, individual ions. That's how the corn plant takes up phosphorus. Yeah, I know, everyone says, well, you know, temperature, soil temperature breaks that down. Yeah, we have a chart on that. We're going to talk about that when you come to the fundamentals of agronomy training. And actually, you can get anywhere between 30 and 95% breakdown as soon as your soil temperature gets to 125 degrees. And so I'm going to suggest that if your soil temperature gets to 125 degrees, we've probably got bigger problems. But the fact of the matter is, it makes a lot of sense to apply phosphorus in the orthophosphate ion. That's the way we want to do this. It also talked about the fact that acid soils, low pH soils where we're at, contain a lot of excess iron and aluminum. And oftentimes this results in a chemical combination that is these available forms of phosphorus become less soluble. In other words, your P2 is less soluble in that situation, and your polyphosphate takes a lot longer to become available and get into that plant. These guys believe that phosphorus has 3 purposes. Number 1, put it on as a starter for immediate stimulation to the plant. Number 2, to provide a continuing supply throughout the growing season. And number 3, to ensure a good reserve supply of phosphorus. And that is really, really important that we pay attention to that. Again, in here it talks about the fact, it is well-known fact, that you only get 10 to 30% of the phosphorus from the current year's fertilizer application. The rest comes from the soil. So we want to make sure that we're putting on in the right way. We want to make sure we're putting on the right product. We want to make sure that we're making an investment that's a good one. And I'm not sure 20% return is it. Guys, we're going to do some work here later. And probably we're going to talk about the value of the residue, the value of some stocks. We've got a guy up west of us here. There's a kind of a hassle that's coming because somebody bought a farm, the previous renter came in and bailed all the stocks, even though it was right in the agreement that he wouldn't do that. And the fact of the matter is there's a lot of nutrients in a ton of corn stalks. And so we want to make sure that we're doing these. One of the things that I find very interesting at the Fundamentals of Agronomy training, we have a slide that talks about where does the phosphorus come from that you need to maintain the perfect phosphorus level in your corn plant, because that's a straight line. And the fact of the matter is the initial source of phosphorus comes from the seed itself, but that is only available, only takes care of you for about 2 days. After about V8, it comes from the soil. As the temperature warms up, V6, V8, somewhere in there, all the phosphorus you need should come from the soil. The question is, how do I get from 2 days to V6 or V8? The answer is I use a good quality starter, orthophosphate, in the seed trench or right beside it. So that's how we're gonna make sure that we get immediate stimulation. That's how we're gonna have a continuing supply, and that's how we're gonna have a good reserve, because the fact of the matter is, the more phosphorus we put into that plant, the more is there is left as residue, and it recycles. And that's important to remember and keep a hold of. Banding puts a readily available P source in the root zone. It is superior to broadcasting. That's Midwest Labs talking there, guys. I mean, this is not a question. This is not new science. This isn't something that we've just developed, but it's readily there. It's ready to go, and we've known this for a long time. Again, coming back, talking about the fact that we have calcareous or alkaline high pH soils. To prevent fast tie-up, banding the fertilizer is advisable. Because the fact of the matter is, if we don't band it, we're not going to get it. Guys, I see these guys fighting this high pH, and it's a challenge, you know, and I see some of them, they've got a P1 of 9, and they've got a P2 of literally 100. And so they say, well, you need to put on a bunch of fertilizer, put on a bunch of fertilizer, put on a bunch of fertilizer. And the fact of the matter is, they're probably not even getting 20%, because that really high pH soil grabs everything that becomes available almost instantaneously and does it. I have not seen anybody successfully build that P1 level in that application. Funny part is, if you take that soil test in July instead of in November or March, you're going to find that that P1 reading is higher. Why? Because as it warms up, the P2 starts to become a little more water soluble. But the fact is that high pH works against you, and it is really important in that situation to band your fertilizer. I've already talked about ortho versus poly and why it is we want to use orthophosphate. And I want to talk specifically about starter fertilizers, because our whole program is predicated on a soil test from Midwest Labs. Our foundational product is going to be a 9-18-9, a 3-18-18, an 8-16-11-2, a 2-15-19-3. Those are foundational products. Those are our starter fertilizers. 100% orthophosphate, non-detectable levels of cadmium, chromium, lead, zinc, arsenic, mercury. And guys, I've looked at an enormous number of tests that have all those heavy metals. It's very interesting. Look this up yourself. Go in, type into the Google search bar, what are the effects of cadmium on seed corn emergence? And I think you're going to find some things that will indicate to you that while they may say, oh, it's only 150 parts per million, it's no big deal, it's well documented that it's a big deal. It's a big deal because it's a cancer-causing metal, and I don't want it near my kids or my grandkids. I don't want it near me, and I don't want it near my seed. So therefore, that's not a product of choice. So I say all that to talk about the fact that we've decided we're going to use a starter. Why do we want to use a ortho versus a poly? We've covered that. Now, the next question is, are we going to buy a fertilizer that's a little more expensive and has 100% pure virgin phosphoric acid that's never been used? Or are we going to buy something that's called spent acid? In other words, acid that maybe was used in the auto industry. They dip those vehicles in them to pull all the loose scale off, all of the zinc, all of the rust right before they paint them. Guys, when the automakers get done with that, they got to figure out what they're going to do with it. So their choices are, you know, pay somebody to recycle it, and that costs big money, or probably give it to someone who's then going to turn around and sell it as fertilizer, or use it as a basis for fertilizer. Guys, those spent acids, they say, well, it's got zinc in it already. Yes, it's got zinc that's tied up with the phosphate, so the phosphorus that you're getting is of no value, and the zinc that you're getting is of no value, and therefore all you became was an industrial dump site. So I don't think that's the way that we want to go. Guys, we are passionate about what we do. I love doing this, and we can talk literally. We're going to spend a couple, 3 hours on fertilizer at the 2-day fundamentals of agronomy training. And I encourage you to reach out, get a hold of us, let us help you get registered. Let's get in there and see what we can pick up, because one new idea that makes you $15 an acre could be a game changer for 2022. I hope you're enjoying this. Again, I hope you share it with a friend. I hope that you slip over to the podcast. We're getting ready to release a really good podcast on Monday on drones. I think you're going to like it. And when you get over there, give us a rating if you would. That being said, I wish you guys a very Merry Christmas, and I hope you're having a better day.